Hi, howdy, welcome back. Levels look like they're good. I might just take the music down a little bit. Oh, I just heard my cat come back in. You might pop in and say hi, but hello, welcome back. It's been a little while. I can't think when the last stream actually was. Probably like a week ago? Yeah, about 7 days. Bang on 7 days to last Wednesday. I haven't done anything since then, because I'm a busy man. Yeah, but it's good. We're back, and we're going to do some more work trying to hopefully get the game loop into play. I have done a little bit, actually. That's a lie. I was on a call yesterday with some of the other Shiba dudes, and we were doing our semi-regular kind of project show and tell code review thing, and I was going through the code for the event-driven reaction system, and something that I wanted to do that we didn't have before was add in support for it, like separating the conditions from the behaviors. So if I just go and we take a look at this debug on white move, what I've done now is added, we've got the usual name for the adjustment, a description for the adjustment, applicable types that it can go on to, the material application, which actually we're going to spend some time refactoring this a little bit more in just a moment. But now we've got the event channel, the reaction that it fires off, and then also the conditions for what what needs to be the case for that reaction to fire. So we can do those as scriptable objects now as well, and it's all following a similar kind of structure. I'm just going to spend a moment talking about the structure of this, so that we're all on the same page. So everything involved is driven by scriptable objects. The reactive adjustment itself is a scriptable object, which takes 3 types of scriptable objects. A event channel, which we discussed again in a previous stream. This is effectively a way of decoupling events from the scene, so I can have them as scriptable objects, assign them to listeners and whatnot, which is, yeah, decouples it from a scene, and allows me to just have events be independent of any specific runtime scenario. We then have a reaction. Reaction defines behavior that should be triggered when receiving this event. And then there's a list of scriptable objects for conditions, which, as I said slightly before, these are Boolean arguments effectively, which will return true or false based on some given condition. So in terms of the way that the code for this actually looks, the reactive adjustment, like I say, basic scriptable object. This inherits from the piece adjustment class, which again, just some abstract scriptable object that we have for defining the, you know, basic stuff that's always going to be consistent for any scriptable object or any adjustment, either movement or reactive. It's got its reaction, and this takes a type of the data and then a type for the event that it listens to. So the data is what it's going to look at or react with, the type of data that it will manipulate in the reaction. And then the event, like I say, is some event data that comes as part of the event that gets fired off. And then the condition has the same arguments. It's a list of condition, which is just a generic taking the piece object and some event data that lines up the same as the reaction. Cool. So what we then have, let's look at the reaction itself. So the way that the reaction works is that it will have a it has a method called handle reaction, which will be called on the event being fired. And this then says if we've got a list of conditions, because maybe we don't want any conditions, we just have it be null. So if there are some conditions, for every condition in that list, if it's not met, then we'll log out a message saying the condition isn't met and return. Otherwise, we'll handle the reaction and fire off some abstract method, reaction effect, which is the actual behavior of the given reaction. And then the condition, again, abstract class, just has a virtual bool check condition, which actually I think we can probably make this abstract and just print out do nothing as a base, because we don't need to do anything. And I think we can also remove this debug line here as well. Cool. And then so to take a look at some implementation, then I've got an implementation of a condition here for piece is color. It's got a boolean is dark, and it's just going to return if the sender object is the same color as the color that we checked in here. And perhaps we would want to change this to some different thing. Like we might want to have this be captured piece is color. So in which case we might add like a public bool is or no, we wouldn't have anything in there. We would have is dark, and then in here we would have something along the lines of if redacted, if data dot captured piece is not equal to null, and where's my and symbol? There's my and symbol. And data dot captured piece dot is dark is equal to is dark, we return true, otherwise return false. But you know, it's all stuff that we can fiddle around with when we get there. And then an example of a reaction, we've got this debug message, which is called debug on capture, but we'll end up deleting these anyway. So it just has a string for a message, and the reaction effect is just to debug that message. Nice and simple. Nothing too crazy going on there. Cool. So what I'm thinking we do with this before we get on to doing the big ticket item for the stream, because I'm also going to be kind of short on time today. I need to be out of the house at 6:15, so probably end up wrapping up around 6, maybe 1:45. But I'm thinking we actually probably move this list down into the reaction, rather than having it on the reactive adjustment. I think that's probably going to be a little bit more friendly. And rather than just have the list be defined straight up here, I would actually like to create like a public class condition list. Perfect. Which is just like that. So this is going to be a list of condition of type piece object and piece generic event data, and we could even you know, take this a step further, make this generic for sender type and data type, and then have this be ST and DT. And then if I remove the list from here, we'll put it down in the reaction instead. The only thing that I think to myself when I'm coding this is maybe I want to be able to have the same kind of reaction, but with different conditions. And actually, we can still do that if we move the list into here. So, bun it. We're going to do it. We'll have a public, what did I call it? Condition list conditions. And then we don't need to pass in a list here. We can just say this equals new. Get rid of our null check on conditions because we've always got a value in there. And we'll say for each condition in conditions, if condition is false, then we say condition isn't met and return. Otherwise, do the reaction effect. Job done. Cool. So now we have this relationship back of being able to have a reaction that would be like debug on capture. Because the condition is tied to the reaction rather than being tied to the adjustment. Lovely stuff, lovely stuff. And we can take a look at what this looks like in practice in a second as well. Oh yeah, that was the other thing that I wanted to do. God, I'm getting pinged left, right, and center. Not gonna deal with that right now. I want to change this material application to be private, and I want to hard code it in each of the subtypes for piece adjustment rather than setting them manually. So rather than having a list of adjustments, I think what we do instead is perhaps have a public material adjustment material. And then when we apply the adjustments, let's make this abstract. Oh, no. Let's not make it abstract. Let's leave it as is. But we'll have a private int not private, sorry, protected int material index. And then we can just say materials at material index equals, whoop, can't type, adjustment material. Cool. And I don't want this to be a list. I want it to be like a multi-check enum. But I still don't know how to do those, so we'll have to take a look in a moment probably to see if we can figure that out. Cool. Okay. So now in the reactive adjustment, I want to do a on enable. I don't want to do this. I want to say material index equals 1. No, 0. And then on the movement adjustment, material index equals 1. Beautiful. I think we're good. Oh gosh, knocking the mic. Remove that accidental import. Same in here. Cool. Now we should be in a good position where everything is how it should be. And I'm going to go ahead and just delete this debug on capture. And that is going to cause me some issues because I'm pretty sure I've got an instance of that. Yeah, the reaction. Reaction behaviors, all of these are debug on React, so I'm going to delete those real quick. And to be fair, I might delete these reactions as well, because I don't think we need them, or at least I don't want to faff around with testing them just yet. What I will do is just go onto my adjustment material and put on my gold stripe material. So in our test chess game on the player pieces, let's turn this guy back into a normal pawn, basic pawn. And then we've got 2 gold pawns on either side, so those are the ones with the movement adjustment. They can step backwards as well as forwards. Cool, so that's all applying fine. They can step backwards, my normal pawns can only step forwards. Everything is as expected, I can still capture. Beautiful. Everything is good. I'm going to shuffle this pawn back. I should have just captured along there, really. Let's try and take the king, because now I'm in a position where I can't really do anything. Oh, now the king's moved forwards. I'm just going to get captured, aren't I? Yeah, there we go. Player loses. Fantastic. Cool. So, now that we've done all of that, what the main thing that I wanted to work on this stream is taking a look at getting our game loop implemented, and I want to do this using a state machine, but not like your normal or your like low level oh, my brain is not with it today. Not your low level like switch statement type state machine that we usually do for a game manager, or like we've done for our match manager, but rather we're going to have an actual state machine, finite state machine, using my abstract state machine implementation, which is available in the Shiba Core utils. There's a link in the description to get that through the Patreon. And the reason I want to do that is because I don't know how many states we're going to have, so I don't want to be using a switch statement. And also the states could have lots of complex logic, like in the update maybe we want to run some things, we want to run some stuff maybe on a certain condition being met within the different states. We want them to be able to exist as their own classes and encapsulate their own behavior, so that we can, you know, switch between them appropriately. So that is how we're going to do our game manager. Which conveniently we've already created a class for. Now, what I would like to do is take a look at my state manager implementation to see if we've implemented this as a singleton, and the answer is no, we haven't. So actually, while we're here, let's just spend a couple seconds explaining how this thing works, and I want to close away my terminal as well. Whoopsie daisy, that's not what I meant to do. I meant to just close this. Go away, please. There we go. Okay, so State Manager is a class that, as you would probably guess, manages states. The way that this works is it's abstract. So we have 2 different classes. We have the State Manager and the State class. The State Manager is an abstract generic class with 2 types. It's got a type of State Manager and an enum for the state, and the conditions are that the enum, the eState enum, has to be an enum, and the tstate manager has to be a state manager that that implements the types tstate manager and eState, and that is kind of yucky, but it makes perfect sense, I swear. Basically, all it's doing is guaranteeing that the state manager, or the type of the state manager that we're using, is this instance of State Manager, and therefore the type of state that we end up having is going to be a type of state that's accepted by the State Manager. From that means we can have a dictionary mapping a state key, state enum, to a given state of type tstate-manager estate. Again, ensuring that our states match the type of the State Manager that we have. We have an estate enum selection option for the key of the initial state that we want to be in. And then we also have a reference to what the current state is, which we're keeping protected, just so that we can't go in and change it from inside. I might just have a public state, tstate, current state, which just returns that so that we can at least read it elsewhere. And then we've got a protected buffer if we're transitioning, which we just use to basically prevent us from being able to transition to a new state if we're already in the transition mode. So you can see here when we do the update, we're checking every frame to see what the next state should be from the state that we're currently in. And then if it's the same as our current state, then we're just going to update all of our substates, which allows us to have a hierarchy, because maybe we want to be able to run some additional state behavior as a child of the current state that we're in. Otherwise, if it's not the same, we want to say if we're not already transitioning to a new state, then we'll call our transition to state with the next state key being called. And that transition to state method, like I say, just sets our transitioning to true, checks to see if we're in a current state. If not, if we are, sorry, we'll exit all of the substates on that state, and also exit from this state as well. And then set the current state equal to whatever the new state should be from that state key, enter that state, and set transitioning to false. And we've also got a method for getting the state by a key, just in case we need to get an instance of a given state. Cool. So our game manager, we still want to be a singleton, and actually, I'm not going to do this in game manager. We're going to make a new class called RunManager, which is going to handle all of this. So I might make a new folder called game loop managers, which I'll go ahead and stick the game manager and the match manager into. And spoiler alert, we're going to be destroying our match manager class and replacing it with one of these states. Or we might perhaps have a match state, and then it can create and manage an instance of the match manager, which I think we should actually probably rename to match controller, because it's a bit more appropriate. Okay, make a run manager. We might make this a singleton, but for the time being I don't think we will. I want this to be a state machine, state manager of type run manager, and we'll have a run state as well, which we can go ahead and create a public enum run state, like so. And then we can just add different states in here for all the ones we need. So, ones that I know we're going to need are going to be, start run. We also want, like, level select. In match. Or just match, I think. Play match, let's call it. Run lost and run one. And like I say, we'll end up adding a whole bunch more to this. Eventually. Cool. So, do I want to override any of the things that we've got in here? I will definitely want to override the start, or at least the awake, because what we're going to end up doing... Can I put you over this side, please? There we go. So, what we want to do... Let's make this private, void, awake. We want to... initialize our states dictionary, and the way that that's going to work is just by saying states equals new, but then we can pass in a load of yeah, perfect, ChatGPT, or not ChatGPT, GitHub Copilot knows exactly what I want to do. It's going to, yeah, exactly this, create a bunch of new instances for a start run state, level select state, play match state, run lost state, run one state, and we'll create all of those as classes in just a moment, but it also then maps them to the appropriate keys for our enum, which is fantastic. Cool, so I think some other stuff that we probably need to have in our RunManager, this is where we're going to have our public or perhaps not public, serialized field, not even a serialized field, it's just going to be a public chess deck, player chess deck, and we'll make this a get private set, which I think we can probably also initialize in some state. And you know, I think we probably don't even need this start run state, because we can just do this when we initialize the RunManager. So we may well have a public void. Whoops. Yo, Bionicle's here. How's it going, friend? What did you miss? Not too much. I'll do a little run over, or run through in just a moment. Ooh. Yeah, you know what? I think we will have the run start run state. Like that. And then we'll have an initialized run, which takes in all of our data. And then once complete, we'll transition to the level select state. Cool. And I mean, to be fair, it could even be the case that we just have some flag on here that is a boolean for checking to see if we've run this method, and then the start run state can actually just set up all our data and transition out when it's complete. I might prefer that. Okay, cool. Right, let's talk about what you've missed, so that we are on the same page. What we've got is basically exactly the same as we had last week, because I think it has literally been a week since we last did a stream, and you'll have to excuse my down-sounding voice. I'm feeling a little rough today, but we move. Respect the grind. So we've got exactly the same as we had last week. We've got our chess pieces working with adjustments, hence the yellow band. We can, you know, play through a run quite happily. I think they're going to move the king. They didn't move the king. I can capture the king, and it will print out a message saying that I've won. Everything's working fine. And the only change that we've made is on our... not utilities, on our board management, piece logic, piece data, yeah, our reactive adjustment. I've updated it very briefly to have a new condition list, which is just a list of conditions where a condition is basically a Boolean delegate. So it will take in some data for the sender and the data, and it will say, you know, is this condition true? If it is, then we can run our reactions, and it will do that for all of the conditions that we assign. That's basically it. We've also made it so that the material index is tied to the type. rather than like being able to set the index manually, because I specifically want reactive adjustments to change the body material of the piece and movement adjustments to change the strip. Am I sick? Possibly. I might be coming down with something. I have like chronic health issues anyway, which tend to flare up every now and then. I think now we might be in one of those now and then moments, or coming into it at least anyway. So, you know, life goes on, I'll live. Ugh, so, what we're doing now is setting up our RunManager, which is going to handle all of the different states that we're going to switch between. And that is going to entail refactoring our match manager to be a state, which in itself is going to be like, yeah, a mini state machine that can handle all of these different outcomes. So, geez, something rather important to keep in mind is that actually the we possibly separate the play state, like the play match state, we separate that out from the match manager, have it create an instance. Yeah, we'll get to it. We'll get to it. My brain's a bit frazzled. Oh, you're sick as well. That's not ideal. I hope you get better soon. Yeah, being ill is rough. Right. Let's create ourselves a RunManager. I'm going to reset all of its things, and we're going to stick the RunManager class onto it. The initial state is going to be start run. That is fantastic. And what I might do for the time being is just have a slot on it for a public, what did we call it? We have it in our scriptables. Board config. I won't have that be get private set, I'll just have that be as is. And what we'll do, after we do all of our state initialization, I might just say, if initial config is not equal to null, we'll initialize our run with the initial config. There we go. We don't need to do that. We want to say player chess deck equals new chess deck initial config dot player pieces. How am I doing chess decks? I pass in a list of board tile data. Player pieces is a list of board tile data. Oh, I need a boolean for if it's dark, so we want to say false. Player plays as white. Although, you know, we're in a position where we can support having the player play as black as well, which is cool. Let's maybe also do the opponent deck. Not minus, equals. There we go. Cool. I think I will also just do a private bool initialized. We don't want this to be private, I actually want it to be public. Which again is going to be get private set. I want to say on awake initialized equals false. And then after this, let's just say initialized equals true. Cool. All right, let's get in and make our first state, shall we? Which is going to be initializing our play. So what I think I'll probably do this as is in my my game loop folder, I'll create a new folder called Run Management, put the Run Manager into there, and then we'll create another new folder called Run States once Unity loads. Run States, I think that's probably below my face, honestly, I can't tell. No, we're good, we're good. Cool, so in here I want to create my start run state. And now this isn't a mono behavior, this is just a regular C# script, so we can get rid of all of this guff. We're going to have it inherit from state, and the type is going to be run manager run state. Let's implement the abstract class and generate a constructor. Carl, hello, welcome. Nice to see you here, nice to see you, I hope you enjoy your stay. I don't think I need to do anything in this start run constructor, because it should do it all in the base. So what the base of the state does, it just sets its own state key to be the key, sets the state manager to be the manager, and then if we need to do any like additional edits, we can. But, you know, for the time being, we don't. So for get next state, I want to say if state manager.initialized with a capital S. So state manager, which is our run manager, that's what gets passed in when we initialize the state. If that is initialized, then we'll return level select. Otherwise, we will return start run. So it's the same as what we're currently in. I don't think we actually need to do any stuff in here. We don't need to init the substate, so I'm just gonna do nothing. Oh my gosh, nothing. Let's copy that. We don't need to do anything in the update state, and we don't need to do anything in the exit state for the time being. And yeah, it's going to be as simple as that for the start run state. The level state, or the level select state, is going to be a little bit different, and I think actually what I would like to do, rather than going into the level select, I'm actually going to go into the play match state, just so that we can like test that this works properly. So actually, you know what, I might do a override enter state, which just runs the base, but we'll run a little debug.log entering start run state, which means debug does not contain a definition for log. Give me the Unity engine debug, and then maybe we do a log in exit as well, just so we know that we are leaving the state. Cool. I think that means we can uncomment this line, and of course we need to pass in the run state.startRun for the key. So we construct the state with its key and also with itself. When we do this, I actually want to return, I think it's state key is what we call it. So state key is the variable in which we're storing that key that we pass in. That's a protected or a public with a private getter parameter. sorry, private setter parameter that we store within an instance of a state. Cool. And then I want to go ahead and create our play match state, which is where things are going to get a little bit more complicated, but we should still be okay to at least do some testing to see that everything works. C# script. Pop this open. It's going to be a similar story. Remove everything from here. You're going to be a state of type RunManager with run state. Copilot has already implemented all of our things and given us our debug so that we can see everything that's going on here. We're not going to worry about initializing any substate stuff for the time being, although to be fair, we probably could just refactor our entire match manager to exist inside this state. But for the time being, I am just going to do some debugs. And what I might do just to have us be in a nice position is actually delete this from the awake method. Let's make sure that we initialize our play state. Again, we need to run state.playMatch as the key. I'm also going to add some spaces in here because I like spaces around my curly brackets when I'm doing initialization stuff. And I'm going to put I'm going to create a public void initialize run from stored config, which just calls initialize run, and I'm going to put a button on this titled initialize run, and that is coming from Odin Inspector. Cool. So what we should be able to see, our run manager now takes a board config, so I'm going to put test chess into there, and it should be the case that when we press this initialize run button, it will plonk us over from the start run state, which is our default state, into our play match state, because we set initialize to true after this, and in our start run state we know that when state manager.initialize becomes true, we enter the play match state. Save. I'm going to just disable the match manager for the moment. I think we could probably put the movement manager into there as well, and we could maybe even make this not a mono behavior, but I'm getting ahead of myself a little bit. Let's just hit play and see if all of this works. Not going to be very exciting. There we go. So entering start run state. If I go onto the run manager, hit initialize run, there we go. We exit the start run state and enter the play match state, and now we are playing a match. Fantastic. So here's now the question of, do we go ahead and completely tear apart our match manager to have as a, like, have it be a state, and we could even create a load of substates for each of the setting up the game, handling the player turn, handling the enemy turn, turn evaluation, player win, lose, and all the rest of it? Or do we just get rid of the initialization stuff and wait for our run manager? Yeah, you know what, for the sake of just seeing everything functioning, let's get rid of our change state thing. We will get rid of the board config because this is being moved out to the game manager. We still want it to have all of this good stuff. We can get rid of this We'll need to do a little bit of a refactor on here. Just to get things working properly. I think what I imagine we'll do, let's make a public void start match, or let's call it initialize match. There we go. Which will do this. I think maybe let's just have a private board size. Like that. We will have private vector 3 board size. We don't need it to equal something new, although impressive that Copilot recognized it as needing a vector that was going to be 8 by 8 for a chess game. That's it's pretty good. It's pretty good. I want a vector 2 int. I wonder if we just new board size.x, board size.y. Bleh. Okay, fine. Undo. We'll make board size a vector 2 int. Vector 2 int. And then here we can say vector 3. Oh no, we do need to do the whole new board size.x 0 board size.y. Oh, vector 3. There we go. Cool. I think we probably actually want to pass in the board. No, let's just pass in a vector 2 int for the board size as well, so that we can say board size equals board size, and then do our game setup. So that way, in our play match state, we will have a reference to a match manager. Serialize field. Private match manager. Let's also have a getter for that. So public match manager. Match manager just gives us back the match manager. Nice and simple. I think I probably want to do a similar thing here. Private board config, initial config. Make that serialized field. We're at 5 o'clock. Cool. So then on our play match state, when we enter the state, let's say state manager dot match manager dot init initialize match, and this takes in our state manager dot player deck, state manager dot opponent deck, and state manager dot initial config dot board size. Cool. Amazing stuff. So now we should be... Oh, has my stream died? Or is that just my browser buffering? It's just my browser buffering. We're good. On our run manager now, we should be able to assign the match manager in here, our initial config, test chess. When we press play, we should just be in the normal state. But when we hit the initialize state button, it should take us through to playing the game. Good, nothing's happening. Go to our run manager. Boom, look at that. And now we've got normal chess as we did before. Ooh, blocked us. I'm going to push, and I'm going to capture. Boom, and we win. So now it'll be a case of like when this fires off, we'd have some event that we listen to that then, you know, triggers up the chain to switch out back into the level brain, you know what I'm trying to say, back into the level select. But this is cool. Okay, so maybe we start working on breaking out our match manager to be this deeper state structure rather than making use of a mono behavior. We just need to make sure that we return the appropriate kind of thing. Hold on a minute. I think I might be neglecting something with how I handle substates. Or substates might be kind of half-baked. So when we update our substates, we're basically doing the same as what the state machine does, where we say if substate is not equal to null, then next state key equals substate dot get next state key. If next state key is equal to substate, then we update the substate, otherwise we transition substate. Transition substate, yeah, same kind of thing. Exits our current substate. Cool, so we can literally just treat the states as state machines. Ooh, it's making me wonder if I make state be a state manager, but that would things could get kind of messy, because then it has to have some initial state, some initial substate. Whereas now we can just do nothing if we don't want a substate. Cool. All right, let's get cracking on that then. So we want the play match. I'm going to put my play match state in there. And then I'm going to create another folder, which is going to be our match states. Whoopsie daisy. Wah! Wah! Although this does make a kind of annoying caveat in that we need to have the E state. So this where's my run manager gone? We need to add all of the different match substates as values in the enum here, which is kind of fine, but also kind of annoying. Let's just have it be match states. And I mean, I think Copilot is going to know what we want, because it is going to line up pretty closely with what's already in the match manager. So, you know what? Let's just go ahead and yoink this. Fix some of our values. I'm going to change this to match setup. Then we got player turn, enemy turn, turn evaluation, which I think we can probably get rid of turn evaluation, because we can just handle evaluating the turn at the end of the state or in the exit state. or in the check transition, rather than having a whole separate state for evaluating the turn. Although maybe we want that, I don't know, I haven't decided yet. And then I think we can probably get rid of the player win, player lose as well, because they're going to be handled in the run lost, run won. So we might just have a end match instead, which is going to be 9. You're going to be 5, 6, 7, 8, 9. This is going to be our overarching, or our main loop states. So we're possibly going to end up with a rather complex enum here, which I don't think is necessarily best practice, but it works. It'll be fine. I can deal with that. Cool. Make a match setup state. Like so. And this is going to be, we're doing this like this, not because we want to set up the data, but because we want to do, you know, maybe some animations and stuff over the course of this state. We can have coroutines in here, which we can run on or run against the state manager, which is a handy little feature. So this can do stuff like spawning in our grid. This is it's basically going to do all the stuff that we've got in the handle game setup that we've got going on here. What we probably want to be able to do is initialize our match state, our play match state with this kind of data. So let's maybe have a public chess deck, which is going to be our player deck, public chess deck, opponent deck, public vector 2 int board size. What else do we need in here? Basically everything that we've got in our match manager is going to come out into this class. So we also want a public bool is player turn, public list of piece object player pieces. That can be get private set. We just want to make sure it's new when the match starts. Same thing for the opponent pieces. We will also want a public enemy AI. This move completed. I don't think we need to worry about that because we'll handle that in the state that's doing the movement. Yeah, cool. I think that should be it. Don't need to worry about the current state because that's already stored. Don't need to worry about the initial state because we're going to handle that in the init substate, which is no longer going to do nothing. All we'll do when we enter the state, we'll update all of our data here. So we're not going to do any of that shenanigans. So we say player deck equals state manager.player chess deck, opponent deck equals the opponent's deck, board size is going to equal that, is player turn is going to equal true. In fact, we're not going to do that. We are just going to say player pieces equals new, enemy pieces, or opponent pieces, sorry, equals new, and I am going to rename our enemy AI to opponent AI. And we'll set it to a new random enemy AI, like we were doing before. Cool. I think that's good. I don't know if we even necessarily... No, we do want to separate this out into a separate separate thing. That's fine. So when we init our substate, which I think should happen in the enter state, let me just look at my basic state class again. Yeah, init substate. So we make sure that we call enter state last so that all of our data is initialized. Let's just put always call the base last. So then in init substate, we will effectively want to say substate equals that. But rather, we don't necessarily want to do... Oh, actually, no, we can just do that because the state can be ephemeral. We don't need... Because the state is stateless, in that it doesn't have anything that we need to keep track of in it. It's just a container for doing the setup, but it can handle all of its behavior independently. We can just make an instance of it. Yeah, we can just make an instance of it when we need to switch into it rather than doing anything too crazy. And I think we want to call this set substate, don't we? Transition substate, there we go. Okay, yeah, we do want to make an instance of the key, perhaps protected virtual void transition substate. Ooh, better idea. Let's just have a bool ephemeral, which we can have false by default. Or no, we'll maybe have it true by default, just so that we don't end up running into any issues if I accidentally forget to put an instance in there, and that way we can say ephemeral. If we want it to be ephemeral, we'll say new. Ooh, yeah, of course I can't. Never mind. So let's we'll do a protected. Is this below my face? I think it is, isn't it? Let's scroll up a little bit so it's higher. Protected void, virtual void transition substate, and this one's going to take a state, new state, but it's also going to take a bool ephemeral, which again we'll set to false by default. So if we're ephemeral, we'll set it to a we'll set it to new state. Otherwise, we'll set it to state manager dot get state by ID new state dot state key. Yeah, cool. That works for me. Great. So then I can go in here and I can transition substate. We are going to pass in a new... I mean, I should just do that. I should just do that. Get rid of the ball entirely. We don't need it. Make sure we got our matching bracket in the end there. Cool. So when we initialize, we are just going to transition into our match setup. And then again, the match setup state is going to handle everything that was in the handle game setup class. Amazing. So this is where stuff's going to get kind of funky. I think we need this camera rig, don't we? So I'll probably put this on the state manager. We'll have a public... I will just make this public transform camera rig transform. Ugh. For get next state, I am going to just return the state key for the time being. That's fine. In our enter state, we're going to do all of this setup. So we're going to say state manager dot camera rig transform dot position equals new vector 3, and this is going to be our we're not going to have reference to our stuff, are we? Because it's in the state. Yeah, so the problem that we've got here... Oh, no, we do, because we've got a super state. We can access our super state. The only issue is we don't know that the super state is a play match state. I guess we can cast it, because we do know that it is, but it's kind of scuffed. It's not really good code practice, I don't think, but we'll allow it. So we're going to have super state. Let's say var match controller with a lowercase m. Match controller equals super state as play match state. That's fine. And then, yeah, we can do match controller dot board size dot x. Match controller dot board size dot y, match controller dot board. We don't have a board manager. We're gonna have to add one of those. And I think we can probably instantiate that. Board manager is a singleton though. So maybe we make it not a singleton. I wonder what that's going to break if I make it not a singleton anymore. Is there anything that's referencing board manager? There is. Amazing. Okay, we'll keep our board manager as a singleton for the time being. We'll come back and undo that in a moment. Or, you know, we could just say when we enter our state, board manager equals board manager dot instance. That's fine. Whoop, board size. Cool, we don't need to do this. Match control dot player deck. Create a piece of position, and then match controller dot player pieces dot add. Similar story for the enemy pieces. Cool. I think that's everything done. We're not going to do anything here. We're not going to do anything in the init substate. And we're not going to do anything in the update state. What I am going to do is just have a private state key next state key, and then we'll return next state key like so, and in our constructor we'll say next state key equals run state dot match setup, and then after we finish all of our initialization, I don't think we even need to call the base on the base state because we're not initting any substate. We'll say next state key equals run state dot player turn. Yeah. Which at the moment is going to do nothing. But you know, we'll sort that out in a moment. Yeah, we'll sort that out in a moment. Cool. I think that should work. I think that should do what we want it to do. So our play match state is going to initialize its substate. Maybe it's the case that we just have a state for handle gameplay, but we know we do want everything to be separate. It's just going to throw us an error because we don't have a state for the player turn, so we'll need to create that momentarily. But I do only have like 30 minutes left, so let's just get the setup going first. Cool. I'll press play. We should be able to go to our run manager. Oh, I haven't initialized the camera transform. I should be able to disable the match manager now, actually. I have just thought we need to get this this event callback in there somehow. So maybe we do create ourselves a listener object. But we'll see. We'll see how I feel. I mean, we could just have the channel on the run manager. Have a bunch of different event channels registered for different types of things, and then, yeah, handle our callbacks there. But anyway, oh, I forgot to assign the camera transform again. Camera rig. Bang. Save. If I now press play, and we press the initialize run button, we should get our board spawning in. Amazing. And then we get an error, like I said, because we have no state for handling the player turn. That's fantastic, though. Cool. And I mean, I think, yeah, we can move indefinitely because it is just our turn, or like the whole time. Nice. Nice. Oh, we'll have to think about things like promotion as well, won't we? Because we want to be able to... Maybe we want to be able to promote. Maybe we don't. We'll see. We'll see. Perhaps promoting just gives pawns some basic upgrade, and we can have like a boon or something, some boon equivalent, which in this game I want it to be Hanafuda cards. And we can have it such that like the promotion behavior is different based on a certain card that you might have in place. Cool. Okay. Right, let's start doing some shenanigans. We want to go onto our RunManager, and I'm going to have a header section for run event callbacks. Have a public piece generic event channel on piece captured channel. Have a public piece. I will have the on piece move channel. I don't think we need to listen to it for anything yet. But we'll keep it. We'll keep it. And that way on our play match state, we can just say when we enter the state, we'll do some stuff. We'll have a private void handle piece captured. Which is literally going to be a clone of our method here. So I'm actually going to just like that. I don't think we even need to do anything fancy. We can just say if it's dark, opponent pieces, that'll remove. Yep, perfect. And then what did I say we were going to do? We're going to say that oh, not that. I want different listeners, don't I? Not channels. We're going to have listeners. Piece generic event listener, on piece captured listener. There we go. I'm not going to get rid of the move. We'll add the move listener. And then we can say that there we go. Similarly, when we exit the state, we will unsubscribe. From that event. Cool. Lovely stuff. Jeez Louise, I am tired. And I am going to have to wrap up soon. We're getting kind of close to time. But yeah, our other states are going to be relatively straightforward to set up, I think. So we'll go ahead and get those sorted in just a moment. I'll probably want to do some good refactoring. Thanks. See you, Barnacle. Have a good one. To be fair, I might call it there because my brain is kind of frazzled. And I'll come back tomorrow with a fresh head, hopefully after some more sleep and a little bit more energy, because I'm struggle bussing right now. Struggle bussing. I've forgotten where I set move completed to true. Handle move completed, and handle move completed listens for the on piece visual moved. Cool. Okay. Save the play match state for the time being. I'm going to actually get rid of player turn versus enemy turn. And we're just going to have taking turn. Like so. I'm not going to change the numbers now. I will only assign numbers to things when they're added, not when stuff is removed. Because I want to make sure it doesn't mess up any orders. Taking turn. There we go. So that way we can say what did I say on my play match state? Player turn equals true. Or actually, let's not do that here. Let's make a setter for it. And then we can do it in our setup state. Make sure it's the player's turn first. Cool. No issues there. And let's actually go ahead and start making some state for the taking turn state. And this I will need to make as a instance on the RunManager. So let's go ahead, create a new run state dot handle turn or taking turn, new taking turn state. That not going to worry about all the rest of them for the time being. I think I will just switch between the taking turn states, although actually we're not going to be able to do that anyway, are we? So yeah, you know what, let's do our turn evaluation states as well. Get rid of match setup because we're not worrying about that. Turn evaluation, end match, jobs are good. And save that, it's going to complain. I am just going to give myself a little comment in here for match states. You know what, sure, let's have our match setup state be just a single instance. That's fine. Play match state. Lovely stuff. And now I need to make these classes, and I've got about 20 minutes to do so. So we'll start off with the taking turn state. Taking turn, turn evaluation, and end match. Actually, you know what? I don't think we even need a turn evaluation state, because we can just do that at the end of the turn when we exit the turn state. Or when we check what state we should be going into. Which I think I said that already. And then decided that actually I was going to have a turn evaluation state. But I changed my mind. Oh no, I need the match manager open still, because we're using that. Match manager. So now we're looking at the handle player turn and handle enemy turn methods. Lovely stuff. So I think we can probably do our event subscriptions in here. So let's have a private eye enumerator wait for movement, which is just going to yield return new wait until move completed is equal to true. And then it can do all of its thing. Let's have a private ball move completed. We will make sure we set that to false when we enter. Move completed equals false. I think let's maybe also just have a cache of our private play match state match controller, so that we've got it. And then what we want to do is actually probably have two separate eye enumerators. Private eye enumerator handle player turn, and a private eye enumerator handle opponent turn. And then we can simply do a check on here to say that. And we're going to do it on the state manager, or run it against the state manager anyway, because this isn't a mono behavior, but our state manager is. So we can start a coroutine on it. Handle the player turn or handle the opponent turn, and then let's do the behavior for this. So handling the player turn, we are simply going to say you know what, actually we don't even need these. We can just say state manager dot start coroutine wait for movement. Nice. And then it's going to run this which again we need to do our handle our callback. So we'll say piece visual dot on piece visual move dot add listener update move completed. Which will literally just set move completed to true. Like so. And then when we exit the state, game piece visual, remove listener, move completed equals false. I think that should be it. Let's do our end state. Bruh, there we go. I'm actually not going to do anything in here for the time being, just because I want to see how we're going to look. I'm going to do a similar thing here that is private run state next state key, like so. When we enter the state, we'll say next state key equals taking turn. And then in our update state, I think we'll handle it in here. And this is basically going to do what our turn evaluation was doing. So we'll have a bool you know, yeah, bool player king alive. Or first of all, let's say if not move completed, we return. There we go, piece.piece data. Piece.piece.piece data. There we go. Is equal to piece.king. And it's king with capitals. Then set it to alive to be true. If we get to the end of there and player king is not alive, we end the match. I think we probably want somewhere to store that value. Same vibe. And then finally, oh yeah, now I remember. We won't be able to set it to taking turn to switch over. We do need the evaluation in the middle, or it's not going to reset. It's not going to reset our thing. We could potentially just do this though. Move completed is equals false. Set the player turn to the opposite, and then we don't need to do any of that because we're still just doing the turn. So let's just do a debug.log. And I am going to make this slightly smart so that I can say if it's currently the player's turn, then we want to switch to opponent. Otherwise, player. There we go. Cool. I think that should be that done. So I think if I press play and click our initialize button, we should be as we were now, for the most part. We'll probably run into some kind of error. Oh, yeah, I need to add the listeners, don't I? Let's just make these as empties underneath. So this is going to be my piece captured listener. You're going to be my piece moved. Yeah, good. Already put it in. Okay, right. Moment of truth. And if this all works, I'll call the stream here and we can continue tomorrow. Initialize run. Okay. Oh yeah, because I need to do some extra stuff for it being the opponent's turn. Like that. Yeah, I'm gonna have to switch out to a different state and come back into this one. That's fine. That's fine. Let's go ahead and make ourselves a evaluate turn state. Which is going to be a state. There we go. Not going to do that. We are not going to do this in the update state. We're going to do it in the enter state. This is going to be... We need to create ourselves a key again. Evaluate turn 7. Give ourselves an entry. I don't think we actually even need to do that. We can get rid of the whole next state key thing. Oh no, we will keep next state key because we want to return it. And I believe we just do that. Same thing, but for enemy. Otherwise, we'll say taking turn, but we want to Did I get rid of my match manager? No, I kept my match controller. Amazing. Cool. That is fine. That's fine. And then in our taking turn state, we are just going to get rid of this and instead put next state equals evaluate turn. Fantastic. And when we enter the state, we're going to start coroutine wait for movement, and in here we want to say if match controller dot is player turn is equal to false. We can do the stuff that we were doing for moving before. So move is going to be match controller dot enemy. Oh no, it is just our run controller state machine. State manager dot opponent. That's what I called it, right? Oh, it must be in my match manager. Dot get move, and it's going to be the match controller dot opponent pieces. Board manager. Board manager. We're going to replace this with our match controller dot board manager. Move piece to tile, and then we yield return. Cool. Lovely stuff. Okay. I think that should be us sorted now. Should be us sorted now. I should be able to play through a game as I was before, but we will actually have the first move as white now instead of black having the first move. Move completed. Oh yeah, we don't need this in the evaluate turn state. We don't care about it there. Alright, let's give this a shot. And that will be perfect timing if we're on the money. RunManager, initialize run, everything starts. Why has it done that? Okay, so it's firing every time. Switches to the evaluate turn state, says both kings alive, switching to opponent's turn. So I guess what are we running into here? I mean, first things first, actually, our selection controller is going to we're going to have to refactor our pieces to listen for the match state, to see if the match is, like, if it's currently the player's turn in the match. So, you know, I'm on time right now. I'm up to my limit of time that I can spend today, unfortunately. But for tomorrow's stream, which I intend on coming back again tomorrow, we will need to set up. What am I doing? Yeah, we'll need to set up the system such that we can actually have the pieces listen to the match manager instead of the, or not the match manager, sorry, the state rather than the match manager. We then will also need to have the we'll need to figure out what the issue is with this turn switching, because at the moment it's, if we look at the order things have been fired off, we can see we've entered the start run state, exited the start run state, entered the play match, entered taking turn, immediately exited taking turn, and entered evaluating turn state, both kings alive, switching to opponent's turn. And then, yeah, it should be waiting for the opponent to take a turn. Evaluating the turn state, switching to the opponent's turn. Have I forgotten to actually switch the turn? Is that what it is? That's exactly what it is. Let's add that, shall we? There we go. I think that should fix a large portion of our problem. We'll still have the issue of, like, the player being able to move their pieces during the enemy's turn, but, you know, we can come and fix that in just a moment. Well, I say just a moment, we can fix that tomorrow. Yeah, there we go. Enemy moves, I move, enemy moves, I move, enemy moves, I move, I move. And now we've entered the end match state. Perfect. Cool. Okay, so we've pretty successfully migrated everything over. We still have, you know, the issue of us being able to move and capture and all the rest of it, but we are staying in the end match state. Everything is as it should be. So we'll just refactor the way that our selection code works, and we should be jobs are good. And hopefully tomorrow, after we've done that, we'll be able to put in more loops, I guess, or more options for the loop. Maybe start building out a node map for what the different levels will be, but we'll see. Until then, thank you very much everyone for watching. Hopefully you enjoyed. If you did, please consider subscribing. We're almost at 1,500, which would be great if we could get there. I'm like itching to get to that milestone. It's very exciting. If you want to see more updates on this and games that other people are working on and the other projects that we're working on in the studio, consider joining the Discord server. There's a link down below. If you want to support the studio and get some fun tools like the state machine that we've been using today, the event system that we use in this game, and a whole bunch of other stuff, consider supporting us on Patreon. Or if you still want to support the studio but don't want to be paying monthly or for as much as the Patreon is, there is a Buy Me a Coffee link in the description and over to the side as well. Thank you very much again for watching, and I will see you in the next one. Cheers.